Clever Cloud is cloud provider that aims to handle all your operations work while it lets you focus on coding. They support variety of runtimes such as Java, Node, Python, Ruby.NET and provide typical add-ons applications might need like databases, Redis cache and Cellar, which is an Amazon AWS S3 compatible service for storing files. They provide transparent pricing with predictable monthly costs depending on the resources you provision. Pricing model is competitive and precise with a per second billing. In this session, we'll deploy 2 applications and a host of auxiliary services to Clever Cloud. One of the applications will be Spring Social to Cloud, which uses Postgres database. And the other application we'll deploy will be Avatar application, which uses Postgres database, Redis for caching, and Cellar service, which is an Amazon S3 compatible service for storing files. It's a simple application that enables us to store images of avatars. I'll leave a link for repositories of both applications in video description. I'll sign in with Clever Cloud using my GitHub account. Once you sign in, you'll be able to manage your account in a web interface called Clever Cloud Console, where you can adjust your profile and other information and manage your projects in your personal space. First application we want to host on Clever Cloud is Spring Social to Cloud, which is a Spring Boot application that connects to Postgres database. Instead of deploying and managing apps through Clever Cloud Console, which is a web interface, we'll use Clever Tools, a command line interface for Clever Cloud. You can use Clever Tools CLI locally and in CI/CD pipelines like in GitHub or GitLab. And the easiest way to install tools locally is to run npm install -g Clever Tools. I already done that on this machine, and once you do that, you'll gain access to the Clever command line interface. Here we display the version, and if you type in pure Clever, you'll see the available commands CLI offers. First time you use Clever CLI locally on the machine, you'll need to log in, which you'll do by using Clever login command, which redirects you to a URL where you need to connect to your account. Here you'll be given Clever token and Clever secret, which is secrets you can use in your CI/CD environments. Since I plan to showcase how to deploy our app locally, as well as through GitHub CI/CD GitHub Actions workflows, I'll copy the values and paste them in our project in a settings, secrets, and variables part. I'll create new repository secret for Clever token, and the same for Clever secret. You can generate new values for token and secret by logging out and then logging in again. I've updated my repository with new values since the old ones were seen by everyone, and you should keep them secret. The project we want to deploy on Clever Cloud is Java Spring Boot Maven project. We have 2 options to deploy this app. One is as a Docker type, and it's enough to have Docker file at the root of your project, and the other one is a Maven project, which will need to create maven.json in Clever Cloud directory. If you're working with Gradle projects, you'll need to create a similar equivalent file, and in there you'll need to specify how to build a project and how to deploy it. So first things first, we'll go to the command line and use Clever CLI to create new Docker type app. So we'll use Clever create. We'll specify Docker type, and we'll call our app SS2C. If you go to Clever Cloud Console to our personal space, we'll see new app creation being reflected in the web interface as well. Next, we need to add Postgres database to our app, which is done using add-ons. Let's get help on creating add-ons. So we'll say Clever add-on --help. We can create, delete, rename, and list available add-on providers. So let's first list providers to see what's available. We see that if we want to use Postgres, we'll need to create Postgres add-on. And we'll use Clever CLI to create a new add-on, give it an add-on type of PostgreSQL add-on, give it the name of SS2C database, and link it to our application by using --link and giving our application name. If we go to our Clever Cloud console, the web interface, we'll see that our database has been created and is running, and in there we can get the connection details as well as the information about the database. If we go to our add-on dashboard, we'll see there's PG Studio, which is a way to access the database over the web interface, where you can see the tables, the data, the triggers, constraints, etc. you have in the database. And if we go to our application, to environment variables, we'll see that the database exposes environment variables through which we can connect our application to the add-on. We'll notice the user is Postgres add-on user, the password is Postgres add-on password, the host is Postgres add-on host, etc. We can get information about environment variables in the command line interface as well by running clever env, and we see the same information. In Spring Applications, you define a way to connect to the database by specifying Spring data source URL, username, and password parameters. And we expect DB URL, DB user, and DB password environment variables, which will not be present in the Clever Cloud case. Instead, Postgres add-on user, Postgres add-on password, and a host of other variables will be present. To account for that, we'll specify alternative data source parameters when profile Clever Cloud is active. And you can do that by specifying comment and then 3 dashes in application properties or 3 dashes in application YAML file. We'll go to our command line interface and specify that the active profile for our application should be Clever Cloud. And we do that by using clever env set Spring profiles active, and we'll set it to value Clever Cloud. We can see the value reflected in the web interface as well. And to show that you can do the same thing in the web interface, we'll set up admin password that our app expects and set it to admin. Our app demands Java version 17, and since we use Docker type deployment, we managed it ourselves. If you use Maven or Gradle type deployment, you might need to set up Java version explicitly, and you can do that by setting up CC Java version. And we'll do that in here nevertheless, just to show how it's done. We have our database set, we have the way to connect to it, that should be enough, and we can run clever deploy to deploy our application. The fact that the app is deploying is also reflected in the web interface, and Clever Cloud uses green-blue deployments, meaning if you already have an application running, the old version will still be running until the new version is deployed, so the downtime is minimum. My first deployment failed because I had too many connections to the database, as the free version only allows 5 connections. If you have too many connections, you can try to reset the database and restart deployment. Once we are deployed successfully, you can go to the domain names, where you can set up your own custom domain name, but also have one that Clever Cloud provides for you by default to test. And we can open our application, see that everything works correctly, and try to log in with admin password we set up as environment variable, and we see that the application is working. Nice. To remove the application, you go to the informations part and remove the application, and you'll need to type in the application name. And you can remove the database similarly by removing the add-on. I've pushed the application to GitHub and created 2 GitHub action workflows to create and deploy app to Clever Cloud. There are workflows that will need to trigger manually by workflow dispatch event, and they follow steps we did in our command line interface, except that first we need to download the Clever CLI, unpack it, and then we can run login, create an app, create an add-on and link it, and set up environment variables. In our deploy step, we'll need to link, first we'll need to log in, then link to our existing app, and then deploy it. Our create workflow expects app name variable, so we'll first go to our settings and create a new variable. We'll call it SS2C, add variable, and now we can trigger our create workflow. This time we'll trigger it with Maven type, and the database name will again be SS2C database. Password for admin user, let's say admin1, and we'll run the workflow. And the workflow goes through the steps we specified, and it shouldn't take too long. Once the workflow is done, we should see our new app reflected in our Clever Cloud console interface. And there it is. The app name doesn't have to be unique, so in order to deploy, we'll have to link it to the app ID Clever Cloud provides. And our deploy workflow expects Clever Cloud app ID secret. So first, we'll create a new secret. And we'll paste in the value from our web interface. And now we can manually trigger our deploy workflow, which would usually be done automatically at the end of your CI/CD pipeline. So we'll go to the Actions tab and deploy it, and run the deploy workflow. Once our deploy finished successfully, we can go to the console to domain names, and actually let's add a custom domain name SS2C, and then open our newly created app. This time we can try to log in with admin1 password just to see if everything is okay. And it is. Nice. I'll link the repository in the description of the video. Next application we'll try to deploy to Clever Cloud is infrastructurally more involved. To test our app locally, we'll use Docker Compose with services for Postgres database, Redis, and local stack, which is a way to simulate Amazon AWS services locally. We'll only need S3 service, which is an Amazon service to upload files. We'll also spin up Redis Insight, which is a GUI tool for connecting to Redis instances and will enable us to see what's going on with Redis cache. Let's start our services by using Docker Compose up -d. We can hit localhost 8080 to get a root of our application, and let's insert one of the avatars to see how the application works. We'll pick an image, insert it, and moments later we'll see an avatar in a list of avatars. We can hit localhost 8001 to connect to Redis Insight. And let's connect to our localhost Redis instance, which is running in Docker, so we'll put up host docker internal and put the name local Redis. We can drill down into our local Redis instance and see we have one cached key, avatar simple key, with LF and PNG cached as an item. If we add another item, let's say donkey, we should have two keys inserted. And there we have two items, donkey and elephant. After we have items cached in Redis, refreshing a page is almost instant. We can use freeware S3 browser to connect to our local stack to see S3 files. So we'll call it local stack. It will be S3 compatible storage. Local stack is running at localhost 4566. Access key is full and secret is bar. And in there we can see our bucket, avatars, and our two images. If we use dbeaver to connect to our local Postgres database and select all from avatars table, we'll see we have two items, elephant and donkey, and we save image URL from our S3 storage. We'll use avatar name as a key for our S3 storage to fetch the image and display it in our web interface. Since we'll use Seller to store files on Clever Cloud, which is an S3-like object storage service, we'll need to include Amazon AWS SDK in our project. In POM.xml of our project will include dependency for Amazon AWS SDK. To use Amazon S3 SDK, you first need to create a bucket inside of a region, and then inside of a bucket you place your files. For seller service there will be no region, but we will still need to define it as a placeholder for the Amazon S3 SDK to work. We have an S3 service with a save file method which takes in the file and puts it in a S3 bucket and returns a URL for the file. We also grant public access to the file because there will be avatar images that everyone needs to see. In our main application class we have enable caching annotation that will enable Redis caching, and in avatar service we have cacheable method which stores the cache when we list all avatars. You can have different cache evicting strategies that will determine when the cache becomes invalid, and we've chose to use the most simple one, that is to evict all entries as soon as we insert or delete any avatar. When we're fetching avatars from the database, I've deliberately placed 1 second delay between each entry so we notice when we are fetching entries from the database and when we are fetching entries from the cache, which should be substantially faster. We currently have our previous application database running in Clever Cloud and will create a new services and add-ons for our avatar application. First, we'll create new application of Docker type named avatar. Then we'll create Postgres add-on and link it to our application. Then we'll create a new add-on for seller. We'll call it Avatar S3 and link it to our Avatar application, and we'll use the smallest plan. Lastly, we'll create a Redis add-on, call it Avatar Redis, and link it to our Avatar application, and we'll use mono plan, the smallest plan. If you go to our personal space, we see database, Redis and S3 running, and our Avatar service has environment variables set up for each of the add-ons. We've adjusted our application properties to use default names that Clever Cloud provides for each of the add-ons, like Seller add-on host or Postgres add-on DB or Redis host. If you look at our application properties, we'll see that for S3 host we use Seller add-on host, Seller add-on key ID, Seller add-on key secret, environment variables for Redis host, and for database we need to activate Clever Cloud profile so we can use Postgres add-on user, Postgres add-on password, and other environment variables related to Postgres. We'll set the environment variable for Spring Active profile to Clever Cloud so the database is connected correctly. Since we have Seller S3 service running, we can use our S3 browser to create a new account and connect to our Cloud Clever account. It will also be S3 compatible storage. The REST endpoint will be this one, access key this one, and the secret will be this one. And if we select our Clever Cloud account, we see that currently we have no files. Since we need to have a bucket in our S3 service and bucket names are global, I recommend you try to create the bucket name before you start working with your application to see if the name will be available. In our case, Avatar S3 bucket is available, and we'll add it as an environment variable in our application called S3 bucket. We can also use Redis Insight to connect to our Redis instance in the cloud. The host will be this one, port this one, logical name Clever Cloud Redis, username default, password this one. That should be enough for the setup, and now we can deploy our app. After the deployment has been successful, we can go to Clever Cloud web interface and try to hit our application URL. In our web interface, we can see our application is running, and if we go to the domain names and hit the application URL, let's try to insert new avatar, panda. And let's try to insert another one, let's say zebra. It should take 2 seconds now to fetch them. And if we refresh, it's immediate. If we look at our Redis insight, we see we have one total key, cache key, and zebra and panda should be cached. Zebra and panda. If we go to our S3 browser, we'll refresh it and we'll see our zebra and panda PNGs in our cloud S3 bucket, avatar S3 bucket. This concludes our brief look at the Clever Cloud provider, where we've deployed 2 applications and connected various auxiliary add-ons. Clever Cloud offers simple interface and extremely competitive pricing, so I recommend you to check them out.